what I do is that I teach resource 9th grade secondary math 1. And to present the problem to you, and you probably already know the problem, but I'll just tell you that my students on testing can perform at about the 3rd grade level if you don't help them. My job is to teach them 9th grade math when they're 6 years behind. And I'm given the same 1 period a day that the teachers down the hall get to teach regular ed students. So in the same 82 minutes, I have to teach kids that are 6 years behind and teach them the same content that the regular teachers are teaching. And this challenge has, come on in, this challenge has been something that I've thought a great deal about how do you present, we can share that if you like. How do you present 9th grade content to students who don't understand 6th grade content? And I've had plenty of people tell me that the answer is that you can't. That these students are unable to learn algebra, they're not mature enough, they can't learn it, they don't have the prerequisites, if they don't know the prior knowledge, they can't learn it. And I will confess that there were times that I believed that too. I still tried, but I believed it. And then I stumbled across, I didn't invent this, I stumbled across some ideas in other places and I started trying them. And I started building a coherent system that started to work for my kids. And to back up, in the old way that I used to teach, I taught in many ways the way I learned. This is the same textbook that I used when I was in high school. It's the same edition. I've had some of these. And this is Saxon, and I did quite well in math using the Saxon method. It taught me to be very quick and efficient with algebra, particularly. But I'll confess that I didn't understand the math very well. I was quick, I was efficient, I could get the answers, but I didn't know really what the X's and Y's stood for. I couldn't explain it to people. And when I taught that way, and in other ways like it, my resource students, it would take all year long to teach linear graphing. It'd be April and May, and I was still teaching y equals mx plus b, and they still were sort of kind of not getting it. I'd spend 10 months on one objective, and it barely worked. And I thought, this can't be right. This can't be the way to go. And what I'm going to show you today is a different way of teaching the same ideas. It gets you to the same place. And it works for my resource students in about 4 weeks instead of 10 months, where they're able to graph a linear equation, they're able to present you with the equation, they're able to make a data table, and they're able to explain to you all the pieces of the equation by midterms of first quarter, or at the very least by the end of first quarter. And I also do the math credit recovery for the regular 9th grade students at my school. And when I do it with them, it takes them 2 or 3 weeks, 2 weeks. They pick it up like that. They pick it up 2 or 3 times as fast as my special ed students. So I want to get back to why kids fail at math for just a minute. My students that are in special ed are not done. They think slowly. They are not done. They believe that they're done because they've been in a math system where the bulk of the class moves at a certain speed and textbooks are in abstract form. Everything starts with the abstract. So when students come to me from the regular classes and they ask for help and they show me what they're working on, it's a page of equations. And I say, well, what does that mean? I don't know. It's a page of equations. Why are we starting with the abstract? I thought we should start with the concrete, then move to the representational, and then move to the abstract. We have to do the abstract. I'm not suggesting we get away from doing the abstract, but we should start somewhere else. So let's look at these 2 patterns for a minute. And if you have graph paper, if you don't, I have some. But you're welcome to do it the way my students would do. What they would do is they would actually draw these patterns on their paper and then try to draw the 4th pattern and try to draw the 0 step. So the way I would describe it is this is step 1, step 2, step 3. And their first reaction is, oh, but they're the same. Of course they're not. I chose them because they're similar, and as you can see, I chose the size of blocks to hide the fact that they're different, but they're actually different. So this math will be easy for you. You're all math teachers, I think. But I don't mean that in a, if you have trouble, ask your neighbor, it's okay. But, but what would step 4 be and what would step 4 be here? And just see if you can make that on your paper. See what it feels like to draw the picture of it. And then I would like to move on to the table and the equation and then show you some other patterns in a little bit. Do you want graphic?
Hi, come on.
I'm out of rulers, sadly.
May I ask a question?
Please.
Is there anything to the fact that the center is a different color, or is that just to make it attractive? Does it represent something different?
I don't know.
I knew you were going to say
I
that.
will, look, we're all teachers here, and I'll tell you that from my perspective, generally, I will choose the center color for a reason. It's not always the case, but you'll notice in the second pattern, it absolutely matters. In the first pattern, perhaps not. But maybe you could tell me why that is at some point. Yeah, I don't know. When we go to make the table, we can decide which one we want to be f of x and which one g. Maybe this one could be f of x? Sure. And this one can be the second one. Do you need more time? A little bit? No, that's fine.
How far are we supposed to go? What would 4 look like?
Yeah, what would 4 look like? What would 0 look like? If you wish, you could do a shortcut over here. You could do this one and you could put the numbers, like, 36 or whatever it happens to be. You could put the numbers. I'm flexible. I would still give you the points. I hear that a lot, actually. How are we doing? More time? A little bit? Okay. Some of you may recognize the blocks. These are algebra blocks, right? I just repurposed them. Stuck magnets on them. Oh, please. Please do. I certainly could. I will be making the video into a DVD if somebody, I can make copies, it's fine, or I can email it. I don't know if you're interested, but I'll make it. Okay. Are we ready to move a little bit, or am I rushing too fast? I know I'm nervous, so I'm going to tend to want to go fast. And I don't like wasting people's time. So if you're done, let's do thumbs up done, thumbs sideways, need just a little bit more, thumbs down, you need a lot more time. Okay, I give you 2 minutes. Yes.
Dave? I've made the same kind of thing. I just took a bunch of old colored folders, purple ones and red ones, and I cut them into squares, exactly that size. Little 3M adhesive, and cut up all those old magnets I got from the rest. And I just keep them on the
Yeah,
board.
use anything. And I don't, who cares if they're nifty plastic blocks? That's not the point. About 1 more minute? Doesn't have color. April Lockwood suggested that if she were in this class, she'd get extra credit for making it pretty, and I said she would need to use colored pencils. In my class, you need to use colored pencils and a ruler if you want extra credit. In fact, if you don't use a ruler, you don't get full credit. Making your work, talking about, just on that point, with struggling math learners, when they've had the message that they're not good at math for a long time, because if you're not keeping up in math, I know some of you are just finishing, if you're not keeping up in math, you end up having one of two choices. I'm dumb or math is dumb. And the problem with my students is they've decided that both are true. And my main job is not teaching math. My main job is teaching confidence. Math is only the method that I do that with. I have to restore their belief in themselves and restore their belief in math. And if you don't do that, nothing else you do matters. It's not about the math. It's about convincing every kid in your room that the math is not the issue. That you can learn it. Of course you can learn it. Why wouldn't you be able to learn it? Of course you can. Everybody can learn this. I could teach my first grader this. This is not that challenging. The issue is that you may have been taught it in the past in a way that was difficult to understand. That's a different question than whether the math is hard. This is not hard math. So let's break it down. Let's see what we understand. Somebody describe to me, let's see some hands, tell me in words what I would do to build step 4 on the first pattern. What goes here? I'm sorry. I'm sorry. Go ahead.
Just your orange block.
Just the orange block?
Yeah.
Are you sure?
Really?
Okay. What do you think?
Yeah, because we're just taking away one off each edge.
One off each arm of the starfish? Okay. Let's check and see if that makes sense. So if I take off these 4, does it make this?
Yes.
Okay. And then, but that's only one example. If I take off these 4, does it make that? Okay. So then I must take off these 4 to get that. Okay, now here's the critical point I would make. It's at about this point that your successful math students say, forget this, can I just write the equation? And in my experience, a lot of math teachers do the same thing. And I would encourage you that if you want to keep your struggling math students with you, slow down and stay in the concrete for a little longer. Don't jump to the abstract, even though that's what you're comfortable with. I was comfortable with that. It's not wrong, it's just, it's not where they're going to be yet. So let's look at this one. What would this one, well, let's back up. What would step 0 be here?
It'd be 4 off each starfish.
4 on each arm on a starfish? Okay. So what I'm going to do is, because those are long, I'm going to put 4, 4, 4, and 4. Is that okay with you? Okay, at this moment I've done something important. I switched from concrete to representation. But I'm trying to do it slowly and carefully and subtly in ways that don't trip the kids up. Because the moment you switch to numbers, numbers are language, and these are kids who also have great difficulty in reading in many cases. And reading numbers is different than reading shapes. It just doesn't work the same. So let's look down here. We kind of understand this pattern. The arms go 4, 3, 2, 1. All right, cool, I get that. What would step 5 be? For that first one? This is where they really get stuck, but it's a good question to ask.
It would have a half a block on each corner.
This one?
Oh, no, I'm sorry.
Or you're looking at this
Down
one.
here, yeah.
Look, take the first pattern and go one more step. Just one more. Sure.
Would it be a negative representation then?
How would you describe it?
I would put it as a negative, and inside.
Well, so obviously with blocks it's hard, but you can make 3. You could say, well, it gets 3 negative blocks, and you can just have that conversation that negative numbers don't work particularly well with blocks. They don't. You can in some ways, but they get a little tricky with blocks. You could do something like that. You could maybe do something more creative than I've thought of. Well, thank you. Let's come down to this one. The second pattern. Let's call this G of X. What does step 4 look like on this one?
I did half a block on each side.
Okay. So you mean
You have to draw it, but.
half, half,
Mhm.
half, and half? Are we good?
And a center.
Oh, wait. And a what?
A center.
Your center block.
One of these? That's one way you could do it. Can anybody think of a different way?
That was just the one block.
Just one block.
Just the one block, yeah.
Just the orange one?
Yep.
Okay. So we have 2 different answers. One was a block with 4 halves, and one is a block with nothing. And I would suggest that there are some other things that we could do too.
So.
Yes, sorry, there's a hand. I didn't see you.
I did a block, the center block and then 2.
Yeah, so it's,
Center block and plus 2.
2 yellows, yeah.
yeah, you're gonna get the same value. Oh,
So
Yeah.
what we've done is we've proposed some solutions, but nobody's explained to me why this should be the case. So explain your reasoning. Why should I have 2 yellow blocks and 1 orange?
The total number of blocks each time is divided by 2. You can
So this
only-
is 5 divided by 2 is 3?
Total number of yellow blocks.
Ah. So his question was, does it matter which color blocks it is? Absolutely it does in this case. So the number of yellow blocks is cut in half. Well, I don't know. Shall we check? Let's take the starfish arm again. If I take half off the starfish arm, do I get this?
Yes.
I could pull them all off, but then I drop them on the floor and it's embarrassing. If I pull half the starfish arm, that sounds terrible, I'm not just killing starfish. If I pull, it grows back, there's starfish. If I pull off half of this starfish arm, do I get that?
yeah.
Yeah. And then if I pull off half of these, do I get that?
Yeah.
Okay. And I'm really fine with the other representation of drawing half, 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 half. I'll tell you that my honors resource kids, that I like to call them, the ones that are at the high end, will do the halves, and the more struggling learners will do the 2 blocks. Because switching to fractions is, again, a further step away from the concrete. What would the next one look like?
Now one,
And?
and one, yeah.
One.
Or 4.
And the next one?
Block.
And
half a block.
Half a block.
So this?
Yeah.
Oh, okay. And the next one? Okay. This is critical. This is going to lead us into some deep conversations about this pattern that don't necessarily show up in the 9th grade core, but I don't know why you would not talk about it if you know this core. What would this step be?
Can I ask a quick question?
Yes?
The fact that the yellow blocks are smaller than the one in the middle, does that ever confuse you?
Every now and then, like I would say this morning, I had some students that, and they should know better because we've been doing this for a whole quarter, but there were some students that said, well, these are half blocks. I said, no, 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 we're just counting blocks.
Okay. Okay, so that's my question.
What I've done is I've submitted a grant to get blocks that are all the same size. What I did here was I looked in my cabinet and found a whole bunch of algebra blocks and said, well, this is what I have, this is what I'm going to use. But I don't recommend using different sized blocks. I would prefer they were all the same size.
That was what was confusing me, is I was
Yeah.
trying to find out an equation for that, but I was like, but the blocks are different sizes, I'm not saying.
I agree. If you can make them all the same size and shape, I think that would be ideal,
No, it's
in
just-
my opinion.
Can I share my idea?
Please, go.
I took a folder, and I cut it into the same size blocks, and I took all my old folders and did that. And then I took all my old magnets that come in the mail for your refrigerator, and I sprayed a little 3M on the paper, and I glued the magnets on them, and I just leave them on the top all along my board. So you just slide them into place before class takes a second. make your
Exactly.
patterns.
Yeah, I have a whole pile of blocks on the side of my board, and I just pull them over and make patterns.
Uh-huh.
So I don't care what material you use, I don't think the material is the issue. Although I would say, if you're dealing with resource students and they're gonna have something on their desk, then what you put on the board should be the same thing with a magnet stuck on it. It should not be something different than they're holding. They don't make that jump very well. So if it's the little algebra tiles, then take algebra tiles and stick a magnet on it. But don't make something different on the board, if you can help it. Okay, can we just clarify really quickly, this should be fast, what goes here?
8 on each arm.
8 on each arm? Okay, all right. Good, I think we understand. Let's leave this, I'm gonna pull this a little lower, just because I want to see. What we've done up till now is elementary math. Do we agree? I think most elementary students could complete the pattern if given a set of dots, or a set of objects. I don't think that's 9th grade math yet. We'll get to 9th grade math. Then we need to fill out a table. So on the first one, how many blocks are at 0? The top pattern, how many blocks are at 0? 17? 4, 8, 12, 16, 17? Okay. How many blocks are at 1? 13? How many at 2? How many at 3? How many at 4? 1, and then minus 3. Now, can you from this pattern tell me what minus 1 would be? So again, this is one more step away from the blocks. I left intentionally a spot here that we have to fill in from the number pattern. What would go on minus 1?
21.
21? Why would it be 21?
Because you're increasing the number by 4 each time.
Ah, so you come up with a rule. So you're saying the rule this direction is plus 4. That's what you said, right? Okay. Good. Let's just at the same time do this one. At 0, how many blocks are on the G of X?
33.
33. How many are at 1? 17. How many here?
1.
At step 1, 17. How about step 2?
9.
9.
5.
2. And then let's continue this down. This would be,
Well, step 4 is.
oh, sorry, this is 3. Oh, yeah. Then this is 2. Then this is 1. Oh, sorry, 1 1/2. Then 1 1/4. Yeah? Okay. So what we're going to need to do is make a graph and an equation for each of these. And you'll notice that I did pick these because they have these 2 steps in common. I just find that attractive. But to make the graph, that's fairly easy. I assume that you're all comfortable making a graph. So let's assume that you would take, I don't want to use the time right now. Let's assume that you would take the time on your paper to graph it, each of them. And you would find that they have different shapes. What shapes would you predict they would have, since you know this? What shape would this one have? Straight line? Why would that be the case? Well, we've only barely talked about the rule. We said the rule is going 4 up as we go up the chart. What's the rule if we go down the chart? It goes minus 4 as you go down. Okay? Okay, so minus 4 as you go down. Okay, fair enough. What's the rule on this one? And what would minus 1 be? think about whichever one of those you like better. Hmm? 65? So, I hear people saying it would be 16, 16, 16, 16 plus 1. Okay. So that would be 65. Fair enough. What's the rule on this one? And can I ask, is the rule easy to see from the table?
No.
Maybe for a few of you. I'm telling you that for many of your students, this is going to look pretty tough. Which is why I built it over here. Yeah.
It seems like the rule going up actually would be a little easier than the rule going down, at least from my
Okay.
viewpoint right here.
Sure, whichever way you like it. So the rule going up is what?
You double and subtract 1.
You do what?
You double the number, then you subtract 1.
So you double the yellows.
Yeah. Well, no, I'm saying the number you have right there in the box, like 17, you double that number, then you subtract 1. Then you
Oh,
subtract
double
one.
it and subtract 1.
Yeah.
Oh, that's interesting.
I subtracted one and then doubled it.
Oh, that's interesting. This is good. This is good. Okay, so to go up, you're saying double and subtract 1. Okay. So if you go down, what's the rule? Well, so if I do 9, make it 10 and then divide by 2. 5, make it 6, divide by 2. 3, make it 4, divide by 2. That works. So we could do plus 1, then divide by 2. That's ugly. There ought to be a better way to do that. I wonder if we can move to the equations. For the first one. So when I teach my students, I talk about it as f of x, or y, is equal to blank x plus blank. And I say, let's talk about this. What does the f of x stand for in terms of this? Total number of blocks. I heard that over here. This, and my students must label every piece of their equation every time. If they don't know what the piece of the equation is, they don't know what they're doing. Getting the answer is not the point. This is the total blocks. What is this one? That's fancy math language. It's how fast the starfish is shrinking, right? Rate of change, slope, how much it's shrinking, sure. I like to talk about it as the growth rate, because they always start with positive patterns, and then later I do negative and they transfer okay. But this is the growth, or if you want, you can talk about slope, or you can talk about the rate, or you can talk about the change. Or you can call it the rule. I don't care. It's as long as they're getting that idea, it doesn't matter to me which term they're using. The idea is that they're getting the sense that that's the one that changes. What's the x stand for?
Figure number.
Hmm? Which step we're on? It's this. So this is what step you're on, and this is what?
Beginning.
How big the starfish is when? At 0. So this is blocks at 0. If you're talking about blocks, then it's the blocks at 0. So now you say, well, how do you get kids to graph this? Because they get confused on the graphing. When I have them graph it, I have them think about doing bar graphs. Because from elementary, they do understand bar graphs. My students do. And so I say, at 0, you have 17 blocks. Well, I don't have room here, but imagine that you've stacked the blocks. And when I'm first showing them, we stack the blocks up on top of 0. And then we say, but I don't want to draw all those blocks every time. Let's just put a dot at the top and erase all these blocks. But that's what you're doing. You're taking all these blocks and you're stacking them up vertically on top of the 3. So you find the 3 and you stack up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that notion of seeing the blocks stack on your block-shaped paper is no problem. Right? That works okay. So that's how they make the graph, is to imagine the blocks being stacked vertically on top of this, which is your x, which is your step number. Right? Aha. It all has to be tied together. Every lesson they turn in needs to have all four: the graph, the blocks, the equation, and the table. They have all four every time. So this, what was I going to say? Yes?
How do you get them to accept the fact that you need to add something at the end with the zero when you didn't start with zero?
Oh,
Have you already talked about that, or like?
boy, that's a good question. Like, why did we
That's
just?
not the rule, we're not,
Why did we decide that we have to know how many blocks are at the beginning?
yeah, that's what I'm asking.
I don't know. A lot of times I talk about allowance, and I say, you start with $2 and you get $1 a day. So what would you have tomorrow? Well, I'd have 3. Okay, good.
What if the start value is zero though?
Oh, yeah, we do that on the first day of school. I do y equals x. So we start with a 0 in that place on the first day. I've not addressed that. Like, why do we have the blocks of 0? I don't know. Because the way I was taught this was the y-intercept. And it was always related to the graph. But it wasn't related to a set of objects or an allowance. If somebody had said to me, what's the linear equation for your allowance? I think I would have been stuck. But I could have graphed it. But I don't think I could have told you how it worked with my allowance. And that's a problem, because I would like to think that the math I learn I can use in the daily situations that match that math. So, does that work? Can I erase this? Because we need it for the next one? Oh. So kids get these two confused, right? Obviously. That's a big problem. Let's put the numbers in here. What goes in these two? What does this one start with at 0?
17?
17? And what's the rule? Is it up 4 or down 4? Is it growing or shrinking? So how do we show that it's shrinking?
Minus.
And my students will come up with that. They never have trouble coming up with that it must be minus. So this one is minus 4x plus 17. Then we say, and this problem I would use a couple weeks in. I wanted this one because I thought you guys should see the exponential and the linear. This is not where I would start the school year. It's pretty close, but I've already done this, but not on the first day. But this is, it goes down 4 for each x. For every step, it goes down 4. That's why these are together. Every x, it goes down 4. And you have to just drill that in, that's the for each for every step, that those two are really connected closely together. And then this is what you start with, hangs off the end. Let's jump to the next equation, because if I have time, I'd like to show you an absolute value one if we can get the time. Because we did that one this morning. This one, f of x, is the total blocks. Then, oh yes, please, thank you. This should be g of x, and then we have something to the x plus something. Okay, and they say, why should it be in that order? I said, well, I don't know, you have to memorize that. But once they understand it more, they start seeing why it should be. But at the beginning, you have to give them the template, plug it in, and then we work on this over time. This is the total blocks. The x is still what? X is our familiar step. Whatever step we're on, that goes there. That's an exponent. X goes in the exponent. Then this one, what goes here? And what goes here? And what goes here? Let me just give you a hint that this is the orange blocks and this is the yellow blocks. Yes? That's why we separated the colors. If you're doing a shift in your exponential or your quadratic or your absolute value or whatever, if you're doing a shift with a constant, it can really help to have it a different color, at least when you're first starting out. You might be able to get to a point where you don't need to do that. So how many orange? So let me picture it this way. If I kept going for a long, long ways this way, I had a really long whiteboard, what would I put?
You never really get
Would I still have the orange block?
Yes.
Even if I went a couple of miles that way?
Yes.
But what's happening to the yellow blocks?
You're smaller, you're slow.
How small would they get?
Very small.
Very, very small.
Approaching 0.
And the common mistake is students will say, well, they go down below 0, because they think in those linear terms. No, no, no. This yellow block keeps getting cut in half until it gets extremely tiny. And I use the example of an airplane that, you know, and the pilot, and the tower says, go half the distance to the ground. Roger, roger, because I used to fly planes. I'm like, oh, 4 Whiskey Charlie, roger that. You go down, 4 Whiskey Charlie was the plane I flew in. So you go down halfway to the ground, and then the tower says, all right, 4 Whiskey Charlie, if you copy, yes. Would you go half the distance to the ground? Sure. So you go half the distance, and this keep going half. Okay. So you go half again, half again, half again. And you get down so close to the runway that you can't see air between your wheels and the tire and the ground. The tower says, okay, you're not down yet, go half the distance to the ground. At what point do you land? You never land, you never get to zero. And that's what we're doing here, obviously, and you know that, is this is approaching my orange block. So you can, if you want, you can bring in a conversation about end behavior and limits. Not saying you have to, but why not? You've kind of already gone there. So, what goes here? This is the one orange block, which, as you'll notice, is also your limit. Right? Doesn't it limit to 1? Am I wrong? Look, I'm a history teacher. I'm going to be honest with you. I'm in special ed, which means I got drafted. I'm just trying to do what they tell me. They tell me to teach 9th grade math, and I do it. But my background is not in math. I've had 1/4 of college math. I'm just trying to make this work. But is this not your limit? You tell me. It is? Yeah? That's interesting. What goes here?
32.
What does? Is this the rule or is this the starting point? Like, which is which? Which one went with the x before?
First one's the starting point.
I was just gonna say, yeah, it seems to me like, yeah, your first one is gonna be your number of yellow things instead of
The
0.
rule went with the
Okay.
X before.
What's that?
The rule went with the X before.
The rule went with the x. The rule went with the x. The rule went with the x.
So that's going to be a half.
So this is the rule, and of course in this case it's a multiplication rule or division if you prefer. Whereas this is the starting yellows. Uh-oh, that's confusing, right? The starting blocks of the blocks that change. These are the blocks that do not change. They're different. That's why I colored them different. They're different. They don't change. They're not part of the pattern. Like they're there, but they're not doing the same thing. So they're part of something else. So the rule, so the starting blocks is how many? 8, 16, 32, 40? No, what? How many?
32.
Crazy. 40. No, what?
32.
I said,
It's a math teacher thing.
We do it all the
Say
time.
one thing, think another, and then write something else.
you get dumber at the board. I know that's true. All right, so 32, and then what goes here? We said that it's getting cut in half every time. So this is 32 times half to the x power plus 1. Cool. I have a, yes?
I was gonna say, how do you explain that it's not minus a half? Like,
I think that's a good question. It's that we already talked about that this is a half. If you want, you could say that this is divided by 2, but
right,
I like to just say we're cutting it in half.
okay.
We're cutting it in half every time. It gets a little harder if you get into like it's changing by 5% or
Right.
and we do some of those. I do those with interest rate calculations and saving for a car, and we do all those. But I would tell you that those take a lot more hand-holding, a lot more support. My students can do halves, but if you get more, and sometimes they can do thirds. But if you get beyond that in fractions, they're
Yeah, I mean, like, yeah, like, we all understand why it's a positive 1/2, but it would be like,
no. I think it's good. And what I would say is,
yeah.
you can always, what I like to do is have them put it into their calculators, we have TI-73s, have them put it in, and then have the calculator generate the table and the graph and match it to their paper at the end, and say, did you get the same thing? And if they put in a minus 1/2, it's not going to be the same thing. Can I show you one more quick pattern? Do you have time? You're okay?
Yeah.
Okay. You can say no. Let's see. Let me do one really fast. Here.
Can I ask a question while you're doing that?
Yes.
What would your first lesson be? Would you just put 2 linear functions up there, or just maybe just 1 linear
The first
pattern, or
day of school,
the first day of functions with blocks?
then I would do y equals x.
Okay.
So that they learn that 3 is 3, 4 is 4, like to see the connection, and then you say, what's X? And they say, oh, it's X. Like, I don't know, I'm not giving enough time to that answer.